All right, let's review a couple of concepts here. As we enter this time where we're going to be looking at free body diagrams and resultant vectors, pretty much explaining the motion and the direction that the forces are going to drive objects, I'd like to review how we add vectors together. And this takes us way back to force tables. Force tables originate around this idea of just how we check our answers for adding two vectors together. It's really a simple concept. So what we have here is at least in my class, I'm going to present something kind of like what we have here. Okay, we've got we have an A vector based off the positive x-axis at a 30-degree angle with the magnitude of 70 newtons, and then a B vector at a negative x-axis, negative 20 degrees at a magnitude of 90 newtons. This is the information we're given to draw our vector. Okay, now this is one of many ways to do this. Some teachers just draw it out for you. I've had some teachers give it to me this way. It's just kind of up to you. What we do here is we start with vector A. We're going to start off this positive x-axis. That's where I would find my positive x numbers. And I'm going to go in a counterclockwise rotation, okay, to draw this. And I use counterclockwise because that's the direction we use for positive angles. So I'm going to go positive 30 degrees, draw my arrow at 70 newtons. Now for my B vector here, I'm going to start here at my negative x-axis, and I'm going to go in a clockwise rotation, this time to signify that I've got, that negative rotation. Now a lot of people are like, well, now you're going up, Mr. Bringhurst. You can't go up if you're going negative. And that's a common misconception. Going up is positive for a y direction, not for a degree angle. So clockwise and counterclockwise, those are circular rotations, which angles are based off of. So if I go a negative 20 degrees, I'm going clockwise 20 degrees. I draw my vector there at 90 newtons, and I'm good. Now from that point on, we need to find our components. Pretty much how much of this 70 newtons and how much of this 90 newtons is dedicated to the x and y directions. To do that, don't guess here. Draw a triangle, okay? Label your sides. So in this case, I'm always going to label the horizontal side x and the vertical side y. And I'm going to label that, and I'm just going to write out sine of my angle, cosine of my angle. And then I'm going to look here, and I'm just going to go, okay, so for sine of 30 degrees, I have my y over my hypotenuse, which is 70, so y over 70. And then for this side length of x here, I'm going to go adjacent over hypotenuse. That's going to be x over 70. Okay, it's a pretty straightforward idea. We takes this 70, times it to the other side, and we've solved for our y and x lengths of that triangle. We do the same thing over here for this triangle. Okay, I write out sine of 20 degrees, cosine of 20 degrees, and I do opposite over hypotenuse, and then adjacent over hypotenuse. And then I solve for my x and y's. Now at this point I haven't added any negatives or anything because I'm looking for just magnitudes, lengths here. But when I go over and I simplify and I write out the coordinates for my A and B vectors, okay, my A vector is going in a positive x direction and a positive y direction. So both my x and y components here are going to be positive values. But my B vector is going to the left. That's a negative x direction. So I put in my 90 cosine 20, but then I'll tack a negative onto the front of it to signify that's going the opposite direction of positive. But it's also going in a positive y direction though, so I'm going to drop that 90 sine 20 as a positive number. Now I add these two values together, and I add these two values together, and I get my coordinates for my C vector. Now that C vector, all it is, we're just going to draw, it's going to show where, if this was an object here in the middle, it's going to show where the object's actually going to go if I have these two forces acting on it. Okay, and so what we do is we'll draw this. I go to the left 23.95, that's a negative direction, and I go up 65.78. You'll notice I kept these both as positive numbers. Since I've drawn my vector, the only reason why I would have kept negative is because I wouldn't have known it had gone to the left. But since I've drawn it going to the left, I don't really feel that need to put the negative in. Now using Pythagoras' theorem, okay, I solve for this length, okay, and I get out 69.98, or roughly 70 newtons. Now also when we look at this, my angle, I need to know what that angle is. Now that's technically a negative angle from the negative x-axis. But as I do this, really, we could put that as a positive value if we want, for the sake of we know what direction it's going. We know it's going in a negative direction. So and those kind of decisions, that's up to the teacher. Okay? If we do our inverse tangent of our opposite over our adjacent sides, if you want to put that negative in there, then you're going to be dealing with negative 70 degrees or so. In my classes, if you've drawn the picture, I'll let you take that negative off and you can put it as a positive 70 degrees. The whole point of doing this is to be able to allow us, when we deal with free body diagrams now, to be able to add values together, okay, vectors together, to be able to find where an object's going to go. Okay. If you have any questions, feel free to email me or reach out. Come before or after school, we can go over some more questions.